Hello everyone and welcome back to the C# Programming Basics series. In the last episode, we looked at how to get input from the user and then use that to make a simple game. We introduced a lot of new concepts and terminology, some of which may have seemed intimidating, and today we are going to break it all down starting with variables. So, what are variables? We can think of them like small boxes in memory that contain information. However, not all the boxes are equal. Every box has a specific type of information that it can hold inside of it. And in C#, we need to explicitly state what type of information every box contains. In order to create or declare a variable, we use the following format. First, we state the type of the variable. Then, we give the variable a name, and of course, we finish the line with a semicolon. There exist many different types. Some of the built-in or primitive and most used types are bool, int, float, double, string, and byte. Let's begin with the int type. Int stands for the word integer, which means a whole number. Some examples of whole numbers are 5, 7, 0, and -3. To make an int variable, we follow the format described earlier. We start with the type, int, then we give the variable a meaningful name, such as age, and we finish with a semicolon. Let's declare some of the other variable types. To declare a Boolean variable, we start with its type, bool, and then the name of the variable is alive. Notice that it is convention to name Boolean variables like a question. That makes it easier to know that a variable is a Boolean from its name. That is why we call the variable isAlive and not just alive. Boolean variables are the simplest of the primitive types, and they can only be either true or false. Next, we declare a string variable, and we have already seen how to do that in previous episodes. We start once again with the type, string, and then name the variable, for example, sword name. Then we have two similar types, float and double. Both types represent decimals, but the difference between them is how much data they store, and by extension, their accuracy. Floats can store half the information that a double can, and are therefore less accurate. But on the other hand, such accuracy is usually only desired in scientific applications, so we can save a lot of memory by using floats. Just like with the other variables, to make a float, we start by writing float as the type, and then a name, float number. And to make a double, we write double as the type, and then a name, double number. Now we have created some new variables, but we never put any information inside of them, which means that the variables are empty. To put information in a variable, we use the equals operator, and we can do that in two ways. The first is right when we are declaring the variable. After we write the variable name, and of course before the semicolon which marks the end of the line, we place an equal sign. And then we write the variable value. To demonstrate this method, let's assign the value 30 to our age variable. So after the variable name and before the semicolon, we add an equal sign, and then we write our value, 30. When we give a variable a specific value such as 30, that is called a literal. Besides literals, we can assign the value of one variable into another. For example, let's assign the value of our age variable into the float number variable. So we first made age equal to 30, and then we add an equal sign after the float number variable and make it equal to age. That is called an expression, and now both of these variables equal 30. The second way is writing the variable name anywhere after its declaration and assigning a value to it using the equal sign there. That looks like this. In this line, we declared a variable and assigned it an initial value of 30. Now we can go a couple lines lower and write the variable name again, age, then an equal sign, and give that variable a new value, let's say 20. Notice that we do not rewrite the type of the variable. If we did that, that would tell C# that we are trying to declare a new variable, which is not true, since we are trying to assign some value to an already existing variable. Now, there is a special thing to remember when working with floats and doubles. When we want to assign a literal into a double, we simply write the number, for example, 3.4. However, when we want to assign a literal into a float, we must let C# know that it is a float by putting an F after the number. For example, instead of H, if we assign 3.4, we have to put an F after the number. And this way C# knows that our number 3.4 is a float, as opposed to 3.4 without the F, where C# knows that it is a double. We will get more into why that is necessary when we talk about casting and conversions, but in short, this has to do with the possibility of data loss, since floats hold less data than doubles. So C# wants to make sure that we intend to use the less accurate number. Also, it is very important to remember scopes. A scope is defined between two curly brackets. It is like a little world where everything that is created inside of it dies with it. In other words, if we create a variable inside that little world, the variable only exists in that specific world. If we try to call or use the variable outside of that world, we would not be able to, since it only exists within its own world. So that means that we can only assign and use our age variable inside the scope where we created it. Let's see if we can determine the scope where our age variable exists. To find the scope of the variable, we search for the innermost curly brackets that wrap it. So we have the namespace curly brackets, which happen to be the outermost ones. Then going one step inward, we have the class curly brackets, so that's another scope that is inside the namespace. And then another step inward, we have the main function curly brackets, which define the main function scope. And inside of those curly brackets, we have our age variable. So these are the innermost curly brackets in which the age variable exists. Therefore, this is the scope in which our variable exists. Now, here is an interesting question. We created an int variable called age inside the scope of the main function. Let's say we make another new scope within the main function by opening and closing curly brackets. Can we use the variable age inside this inner scope? Pause the video for a moment and see if you can figure it out. If you said that no, unfortunately that is not correct. We can indeed use our variable age inside this new inner scope, and that is because this scope is still inside the world where our variable exists. It is true that we are using it inside a different world, but this new world exists within the old world. So we are not actually using the variable outside of its own world. Now let's create a new int variable inside of the inner scope. For example, int height. Can we use this new variable inside of the main function but outside of the inner scope? For example, over here. The answer is no, because in this case we're going out of the world where the height variable was created. At this point, the world that contains the height variable is destroyed, which means that height no longer exists, so we cannot use it. It can get a little confusing, but I hope this makes some sense, and with more practice you will get used to it. Thank you so much for watching, and I hope that you have learned something new today. This has been your friendly programming guy Alex, and I will see you in the next one.